Minus 7 minutes, and there goes retraction of the crew access arm. This is the walkway attached to the service structure and used by the crew to walk across to the orbiter. The crew has been advised to lower their helmet visors, and at T-minus 6 minutes, we'll begin preparations for starting of the auxiliary power unit. The APUs are turbine devices fueled by decomposing hydrazine liquid, which provides hydraulic power to change the angle of the engine, to operate the aerodynamic surfaces, engine valves, and during landing, operate the landing gear. Coming up on the T-minus 6 minute point in our countdown.
That's it, Mark.
T-minus 6 minutes and counting. The pilot, Dick Cooley, has begun the APU pre-start activity.
Your pre-start is complete.
And it is complete. The development flight instrumentation, which measures stresses on the orbiter during flight, have been turned on. Recorders stop for playback after landing. T-minus 5 minutes, 40 seconds, and counting. T-minus 5 minutes, 30 seconds. And pilot Dick Cooley has signified the auxiliary power units are ready to be started. T-minus 5 minutes, 15 seconds, and counting. We're coming up on the T-minus 5 minute point. 2, 1, T-minus 5 minutes. We have a go for APU start, and the start sequence has begun. T-minus 4 minutes, 44 seconds, and counting.
That's that work. Minus 4:30.
T-minus 4 minutes, 30 seconds, and counting. We have a total of 16 minutes of hydrazine supply for running the APUs prior to a liftoff.
Okay, APU start is complete. Looks good on board.
APU start is complete. T-minus 4 minutes, 10 seconds, and counting. T-minus 4 minutes. We have begun nitrogen purge of the main engines on the orbiter. T-minus 3 minutes, 50 seconds, and counting. T-minus 3 minutes, 45 seconds. The elevon, speed brake, and rudder are being moved through a pre-programmed pattern to assure that they'll be ready to be used in flight. Little exhaust from the APUs coming out the tail of the orbiter, indicating that all is well. T-minus 3 minutes, 28 seconds, and counting. The shuttle is now on internal power. However, the fuel cells are still receiving their fuel from the ground support system through the tail service mast for 1 more minute. T-minus 3 minutes, 15 seconds. The profile checks of the aero surfaces have been completed and checked. T-minus 3 minutes, 5 seconds. The engine gimbal or movement check is underway to assure that they're ready for flight control. T-minus 2 minutes, 55 seconds, and counting. The lock valve on the external tank has been closed and pressurization begun. After the tank is pressurized, the hold capability is limited. T-minus 2 minutes, 40 seconds. We have cleared the caution and warning memory. The gaseous oxygen vent arm is being retracted. T-minus 2 minutes, 30 seconds, and counting. The fuel cell ground supply of oxygen and hydrogen has been terminated, and the vehicle is on its onboard supply. T-minus 2 minutes, 15 seconds. The main engines have been gimbaled to their start position, and the pressure on the liquid oxygen tank is at flight pressure. Coming up on the 2 minute point. T-minus 2 minutes, minutes and counting. The liquid hydrogen vent valve has been closed and flight pressurization underway. T-minus 1 minute, 50 seconds and counting. The gaseous oxygen vent arm is almost fully retracted. T-minus 1 minute, 40 seconds and counting. T-minus 1 minute, 30 seconds, 90 seconds away from launch of STS-2. T-minus 1 minute, 15 seconds and counting. The liquid hydrogen tank is at flight pressure. Coming up on the 1 minute point in our countdown, everything going smoothly. T-minus 1 minute and counting. T-minus 50 seconds. The firing system for the ground suppression water is armed. T-minus 40 seconds. Development flight instrument recorders are on. T-minus 37 seconds. We're about just a few seconds away from switching control of launch to the computer sequences. We have control of the countdown now being conducted by the launch sequencers on board the orbiter. T-minus 20 seconds and counting. The SRB hydraulic power units have started. The SRB nozzles have been moved to start position. Coming up on 10, T-minus 10, 9. We have go for main engine start. We have main engine start. Minus 3, 2, 1. We have ignition. We have ignition of the solid rocket boosters and liftoff. Liftoff of America's Space Shuttle, and the Space Shuttle has cleared the tower.
Houston now controlling. Mission control confirms roll maneuver started. 20 seconds. Thrust looks good. 25 seconds. Roll maneuver completed. 30 seconds. Columbia now 1 nautical mile in altitude. 35 seconds. Status check and mission control by Flight Director Neil Hutchinson. Given a go at 40 seconds.
Columbia, Houston, your go at 40. Roger, go at 40. And master arm, and it's the...
48 seconds. Throttling engines down for execute.
Roger, ignore the master alarm, Columbia. Okay, no.
Coming up on period of maximum aerodynamic pressure on the vehicle. Mark 1 minute. Columbia now 5 nautical miles in altitude, 3 nautical miles downrange. Velocity now reading 2,300 feet per second. 1 minute, 8 seconds. Pass through max Q. Columbia still looking good. Throttling engines back to 100%. Mark 1 minute, 20 seconds. Columbia now 9 nautical miles in altitude, 6 nautical miles downrange. Velocity now reading 3,000 feet per second. Mark 1 minute, 35 seconds. Columbia now 14 nautical miles in altitude, 10 nautical miles downrange.
Houston, you can expect any BAP, C&W.
1 minute, 45 seconds. Coming up on negative seats where altitude's too high for ejection seat.
Negative seats. Roger, negative seats.
Mark 1 minute, 55 seconds. Columbia now 21 nautical miles in altitude, 18 nautical miles downrange. Velocity now reading 5,000 feet per second. Standing by now for solid rocket booster separation confirmation.
50 at 205. Roger, copy. PC less than 50. Okay, looks like we got a good SO.
Confirm good solid rocket booster separation.
Smooth as glass, Houston.
2 minutes, 25 seconds. Onboard guidance is converging as programmed. Columbia is now steering for its precise window in space for main engine cutoff. Columbia now 35 nautical miles in altitude, 40 nautical miles downrange.
Okay, Houston, we got the temps are coming down and looking good. Roger, Columbia, thank you.
Mark 2 minutes, 45 seconds. Columbia now has 2-engine landing capability at Rotor Naval Air Station, Spain. 2 minutes, 54 seconds. Status check and mission control. Given a go for 3 minutes.
Columbia, Houston, you're looking good at 3.
Roger, copy. Looking good at 3. Mark, 3 minutes, 8 seconds. Columbia now 46 nautical miles in altitude, 66 nautical miles downrange. Columbia's 3 main engines continue to run smoothly. Ingle and Truly really moving out now. Velocity now reading 6,700 feet per second. Mark, 3 minutes, 30 seconds. Columbia now 52 nautical miles in altitude, 85 nautical miles downrange. Velocity now reading 7,000 feet per second. Return status check and the mission controlled by Flight Director Neil Hutchinson. Ingle and Truly given a go to continue. Mark, 3 minutes, 55 seconds. Columbia now 58 nautical miles in altitude, 112 nautical miles downrange. Velocity now reading 7,900 feet per second. 4 minutes, 8 seconds, standing by for a negative return and pressed ATO call-ups by Capcom Brandenstein.
Negative return. Mark, negative return.
Roger that. Sounds good. With that call-up, Ingle and Truly now committed to space travel. They can no longer turn around and return to the launch site. 4 minutes, 35 seconds. Columbia now 60.
Columbia, Houston, you're pressed to ATO.
Press ATO. 4 minutes, 44 seconds. For the first time, Columbia has forward abort-to-orbit capability on 2 engines by throttling engines up to 107%. Columbia now 68 nautical miles in altitude, 189 nautical miles downrange. Velocity now reading 10,300 feet per second.
Columbia, Houston, your normal throttle.
Copy that, normal throttle. 5 minutes, 14 seconds. That call up by Capcom Brandenstein says that Ingle and Truly now capable of abort to orbit on 2 engines without throttling up Columbia's engines. 5 minutes, 25 seconds. Columbia now 68 nautical miles in altitude, 228 nautical miles downrange. Mark, 5 minutes, 40 seconds, standing by for press to MECO.
Columbia, Houston, you're pressed to MECO.
Roger, press to MECO. 5 minutes. Really smooth. 5 minutes, 55 seconds. The press to MECO call from Capcom Brandenstein says, should Columbia lose but 1 engine, press on, keep flying forward. Columbia's engines have enough energy to achieve normal attitude.
Single engine rotor and everything's looking good.
Okay, Dan, single engine rotor and looking good here. Mark, 6 minutes, 18 seconds. That report from Cap